video, let's take a look at solving exponential equations. So I wrote down a few techniques on how to solve exponential equations. So these are a little bit more complicated as compared to the other types that I showed you in the previous video before. So these are a little bit more complicated exponential equations. So the techniques here are make the base the same, which is using your base exponent property, like the one I showed you before. Okay, if you cannot make the base the same, what we can do is either take a log on both sides or take a natural log on both sides. Now, these the second and third technique are designed for equations that only consist of two terms. Okay, so these are the three basic techniques. There's last two problem I'm going to show you use a different type of technique. So let's go ahead and get started. Solve the following exponential equations, write the exact answer, and also round your answer to 4 decimal places. So this problem here on the left, I only got two terms. So there's no way I can make the base e the same as base 5.8. So if I cannot make the base the same, then what I can do is take a natural log or logarithm on both sides. So for this problem, I would take a natural log on both sides because natural log and your e kind of cancel each other out. So my answer will simply be x equal to natural log of 5.8. That will be my exact answer. And approximately, let's put it in the calculator. Natural log of 5.8 is about 1.7579, round to 4 decimal place. All right, this one is not too bad. All right, this one here on the right involving with 3 different terms, okay? But the -3 and the 803 are like terms, so I can combine them first by moving the -3 over. So I get 2 times e to the 2x minus 5 is equal to 806. All right, so to get e by itself, I can divide both sides by 2. So that will give me e to the 2x minus 5 is equal to 403. So when I take a natural log, in a way, take a natural log or logarithm on both sides, when the base cannot be the same, in a way, it's actually applying the power rule, okay, for logarithm, where the exponent will actually come to the front. It has that same effect to it. All right, natural log and e cancel each other out, so the only thing I got left is the exponent, 2x minus 5, is equal to natural log of 403. I'm going to purposely put this 403 in the parenthesis to indicate that the 403 belong to the natural log. Because to get x by itself, I'm going to move my -5 over, which will be a separate term. So this is 2x equal to natural log of 403 first, then plus 5. So this is 2 separate terms, okay? This is 2 separate terms here. Now, to get x by itself, divide all the terms by 2. So my exact answer will be natural log of 403 plus 5, then divided by 2. All right. So let's put this in the calculator real quick. I'm going to figure out the top first. So I'm going to say natural log of 403, close parenthesis, then plus 5, see what that is, then divided by 2. So my answer is about 5.4995. All right. Now this one here on the left, all right, I cannot make 17 into a base 4. So if I cannot make the base the same, what I'm going to do here is take a log on both sides. Because taking a log on both sides by the power rule, then the exponent will actually come to the front, becomes a multiplication with the log. So that will be 2x minus 8, 2 terms. Both of them will multiply log of 4. All right, which is equal to log of 17. Now I put them in a parenthesis, so just easier to write it this way, because when we enter in the calculator, we will also see the parenthesis. All right. So now my x is trapped. So this is only two terms right now. Okay. My first term on the left, the variable x is trapped inside this parentheses. So I will have to do a distribution. So I'm going to take my log of 4, which is an irrational number. I'm going to do my distribution, and I will get 2x times log of 4 minus 8 times log of 4, which is equal to log of 17. All right, so now I got three terms. My variable term is a term that contains the variable, which is 2x times log of 4. So since I only got one variable term, that means I'm going to move my negative 8 log times log of 4 to the other side. So I get 2x times log of 4, that is equal to log of 17, plus 8 times log of 4. Log of 4. Yep. All right. So this is only one term, right? So x is a variable. So 2 and the log of 4 got to be the coefficient. So now I just divide all the term by the coefficient, which is 2 times log of 4. So my exact answer, x, will now equal to log of 17 plus 8 times log of 4 over 2 times log of 4. All right, so in the calculator, I'm going to put the top in the first, which is log of 17 close parenthesis plus 8 times log of 4. All right, so that's the answer. Divided by 2 times log of 4 is only one term, so I don't need, well, just in case, I'm going to put a parenthesis because I want the 2 times log 4 first before it get divided by the top. So the 2 times log of 4. Close parenthesis for the log of 4, close parenthesis for my whole entire denominator. So my answer is about 5.0219. Okay. Now I'm going to bring this problem down here. This is one of the harder ones. All right, very interesting problem because I got base E and I got base 4. So I need to take a natural log so the natural log can cancel out with the E. So let's give this a shot, okay? Couple of things here before I write. This first term here is 5 times e to the 3x plus 2. So when I take a natural log of this term, it's almost like natural log of 5 times something. So according to the product rule, the multiplication will actually becomes an addition. So that means when I take a natural log on both sides, I actually get natural log of 5. The multiplication becomes an addition plus natural log of e to the 3x plus 12. Is equal to natural log. Oh, power rule. Power rule says the exponent will actually come to the front, becomes a product, will be a product with a natural log. So that'll be 3x over 5 times natural log of 4. All right here, natural log and e for this term cancels out. So I just end up with natural log of 5 plus 3x plus 12 equal to 3x over 5 times natural log of 4. All right, so now I got three terms, right? One plus sign here is two separate terms. So, excuse me, four terms. 2 plus sign here is three terms. Positive 3x is a variable term. Positive 3x over 5 times natural log of 4 is another term. So I'm going to have these two terms put together on the same side because if I can have the x's on the same side, natural log of 5 plus 12, right? equal to 3x over 5 times natural log of 4 minus 3x. So what I can do now, okay, is eventually I can factor out the x. Okay, now before I factor the x, let's get rid of this denominator 5. So I'm going to multiply every term by 5. So that would be 5 times natural log of 5 plus 60 is equal to, this cancels out, that's the whole idea. I end up with 3x times natural log of 4 minus 15x. And it makes it easier. It makes it easier to key in the calculator here in the minutes. Factor out the x between these two terms. That's how I make a variable. This is how I made my variable x trapping in two terms into a single lettered variable. So that will be 3, factor out the x, that will be 3 times natural log of 4 minus 15 is equal to whatever this is on that side. So now this is only one term on the right. So to get x by itself, I will divide both sides by this 3 times natural log of 4 minus 15. Or divided by this coefficient every term. So my final answer, my exact answer will be x equal to 5 times natural log of 5 plus 60 over 3 times natural log of 4 minus 15. All right. Now, a little bit trickier to key in this calculator. I'm going to figure the top first, okay? So that'll be 5 times natural log of 5 plus 60. Now, this 60 is something I'm going to divide it by. I got two terms down here, so I'm going to open up the parenthesis for the two terms. 3 times natural log of 4, close parenthesis for natural log of 4, minus 15, and close a parenthesis for the entire denominator. So the calculator automatically see this part as two terms, okay, in the parentheses. So it will do the 3 times natural log of 4 first before it gets subtracted. All right, my answer, negative 2.768. Negative 6 point. All right, let's try another 2, very similar to it. Okay, both of these I got to take a natural log, so I'm going to do this one first. All right, so the purpose of natural log is so it can cancel out with the e. So at the same time, bring the exponent down. So I get negative 2x plus 3 is equal to 2x plus 9 times natural log of 24. All right, again, I got to do distribution to bring the variable term to the outside. So natural log 24 is an irrational number, so it's just some sort of coefficient. We just don't evaluate ahead of time because it get messy. So this is going to be negative 2x plus 3 equal to 2x times natural log of 24 plus 9 times natural log of 24. All right. So now I got 4 terms here. This is my variable term, so is this one. So I'm going to move this negative 2x to the right, at the same time move the positive 9 times natural log of 24 to this side. So I get 2x times natural log of 24 plus 2x. 3 on the left side, still 3, minus 9 times natural log of 24. So I don't have to factor out the 2 here. I just need to factor out the x. So that'll be 2 times natural log of 24 plus 2. Because I'm going to divide this part as a coefficient here. So my final answer, divide both sides, divide every term by the coefficient. My x will just be 3 minus 9 times natural log of 24 divided by 2 times natural log of 24 plus 2. All right, punch in the calculator and see what you get for the and round to 4 decimal place. Okay. All righty, I'm gonna move these guys down a little bit. All right, so this one is very much the same way, except this one I actually have a base e on the exponent, so that makes it a little bit interesting. Oops, sorry. Still, to get rid of the e, I gotta take a natural log on both sides. So this is gonna be 3x plus 9 equal to e times x plus 11 coming down to the front times by the natural log of 47. All right. Again, distribute here to bring the variable term to the outside. So that's 3x plus 9 times e times x times natural log of 47 plus 11 times natural log of 47. So don't let this ex kind of throw you off. E just going to be 2 point something, right? It's an irrational number. So we're treating this like a coefficient in front of the x, but just like the natural log of 47. So so just like the previous problem, this is a variable term. So is the 3x. So I'm going to move my 3x to the right. So that will give me e times x times natural log of 47 minus 3x, 9 still 9, positive 11, natural log 47 come over, become negative 11 times natural log of 47. All right, so factor out the x again between these two terms. So that will give me e times natural log of 47 minus 3. (11 times natural log of 47). All right, so to get x by itself, I just got to divide it by this coefficient on both sides. So my exact answer, 9 minus 11 times natural log of 47 over e times natural log of 47 minus 3. Okay, so tap in these two terms on top first, just like I did earlier. And then divided by parenthesis e times natural log 47 minus 3 close parenthesis. All right. Now, these guys are 3 terms. The last two exponential equation is 3 terms. So these are called, these type of problem, I can't just take a natural log. It's not going to work. So these type of problem is actually called quadratic in form. All right, let me show you what that means. If I would move the positive 40 over to the left side, e to the 2x minus 3 times e to the x minus 40. How is this quadratic in form? Well, it's kind of interesting. This technique called the U substitution. You let another variable, you use another variable to represent somebody in your equation. And what we want to do is substitute e to the x. I'm going to use e to the x as another variable because, check this one out, e to the 2x can be rewritten as e to the 2x whole thing to the first. It can be rewritten as e to the first whole thing to the 2x power. It can be rewritten as e to the second whole thing to the x. Okay, this is all power rule. Or I can write it as e to the x whole thing squared. Because if I can see it this way, that means every e to the x I see representing a u. Okay, representing a u. So my e to the 2x, if I say, using another variable called the U substitutions. Use another variable to substitute something in your equation. If I say e to the x is my u, that means e to the 2x becomes u squared. Okay, this e to the x is going to be u, so that will be minus 3u minus 40. So what I got myself here is actually a quadratic equation. That's why this type of problem is called a quadratic in form. All right, so let's solve for u by factoring. I believe I can use what, 5 and 8. I need a negative 3 in the middle. I need negative 8, positive 5. All right, so u is going to equal to negative 5. U is going to equal to positive 8. So we're not just solving for u, we're solving for x. So now from here, I'm going to bring back my e to the x. So every u is e to the x. So what we're saying here is, it's really e to the x is equal to negative 5. It's really e to the x is equal to 8. Okay. Now I'm solving for x. I only got 2 terms. I can take a natural log on both sides for both equations. So natural log and e cancels out. Natural log of a negative 5 cannot be defined, right? Doesn't exist. So I cannot take a natural log of a negative. But this part right here, my x is going to be natural log of 8. All right. If you put in the calculator, it should be about 2.0794. Okay. So that's my only answer I have. Okay. This doesn't exist. All right. Same thing with this one. Okay. This is called a U substitution, using another variable to substitute something in your equation. Very powerful technique called the U sub. All right. So here, if I would do the same thing, let u equal to e to the x again, my first term become u squared minus 2u for the second term, minus 1 equal to 0. So now this is not factorable. So I got to use quadratic equation or quadratic formula. All right, my a is 1, b is negative 2, c is negative 1. So that will be negative b plus minus square root of my b squared minus 4 times my a times my c, which I think inside the square root times by over 2 times a. Inside the square root, I think it's going to be 8. So negative 1 times negative 2 is positive 2 plus minus square root of 8 over 2. I'm not going to simplify this because this actually represents, this is what u equal to, okay? So what I'm really interested in, here is, well, I can simplify this if I want to. Well, let's simplify it here in a minute. Let's just go ahead and simplify. So, all right, square root of a can be broken apart. So that will be 2 times square root of 2, right, over 2. When all 3 numbers on the outside can be reduced, we reduce them. So that's going to be equal to, maybe it's easier to put in the calculator this way. All right, they're all going to be 1 now. So if the denominator is 1, I'm not going to write it. So that would be 1 plus minus, just simply square root of 2. So this is 2 different answer here. So my u is equal to 1 minus square root of 2. The other u is equal to 1 plus square root of 2. All right, so now bring back the e to the x. So it's e to the x is equal to 1 minus square root of 2, really? It's really e to the x is equal to 1 plus square root of 2. All right, so I'm going to figure out what 1 minus square root of 2 is first, okay? If it's a negative, then I cannot take a natural log on both sides. Yep, it is negative. So this answer don't need to exist. All right, so this one, take a natural log on both sides. My exact answer, x is equal to natural log of, this is 2 terms go together with a natural log. So my exact answer is natural log of 1 plus square root of 2. My approximation, natural log of 1 plus square root of 2. That'll be about 0.8814. All right, so these problems are a little bit more complicated as compared to the basic exponential equations where we could have made the base the same. So if the base cannot be made the same, all right, then we can take a natural log on both sides to cancel out with the e, or take a log on both sides when the bases are not e. All right, so that will conclude this video. Thank you for watching.